drop the headset. Alright, it may have been recording when I dropped that headset, but I can edit it. So let's take a look at part 2. For our Scale 1C Day 2 solving rational equations, this past week we've had difficulty with the internet, and in uploading the videos and stuff, it just didn't work. And even on the recording and stuff, everything was sluggish, and it just didn't seem to be working properly. But it is working much better today, so I've made several videos. Let's finish this part 2. I believe that I did 1 through 6 on the previous video, so let's start with, I have no idea what that just popped up on the screen was. Alright, so when we look at these rational equations, and if we have a variable in the denominator, let's factor all the denominators first. So here on the left hand side I have a single term, and this x plus 3, I can't do anything with that in the denominator. On the right hand side of this first term, I can definitely factor this denominator. Now I am hoping that it's x plus 3 times x plus 4. By the nature of these problems, a lot of times, so they're not too terribly long, you'll have one or both factors over there. So 3 times 4 is 12, and 3 plus 4 is 7. So hey, I got lucky that I just noticed they gave me the factors over there. That's not always going to be true, but most of the time it will be that you'll have one or both of those factors. So now we can easily look at each denominator and see what factor we want. To find a common denominator, you multiply the denominators together. Well, the x plus 3 times x plus 4 is the denominator I want. So on the left hand side, I'm missing that factor of x plus 4. So our technique that we've seen many times in equations is to multiply by the number 1, but to write 1 as a fraction, or I often say in disguise. This is not a normal way to write the number 1, but if the numerator and denominator are equivalent, then hey, we're multiplying by the number 1. Kind of. I'll talk about that in just a second. So on this first term here, I have the denominator I want, so I don't do anything to this term. On this second term on the right hand side, I am missing a factor of x plus 3. So we multiply by the number 1, but we write x plus 3 over x plus 3, which that is going to be the number 1, provided that x is never equal to negative 4, or provided over here that x is never equal to negative 3, because undefined by undefined does not simplify to 1. Now, there is a step in this problem that I generally skip just because it clutters my solution, and sometimes maybe it could cause unnecessary confusion. I always just tell people, hey, the denominator clears. I'm careful not to say cancel, because technically what I should illustrate is that if I multiply every term by this x squared plus 7x, or in factored form this x plus 3 times the quantity x plus 4, all those in that situation, those factors will cancel, and what I'll be left with is just the numerator. But in order to simplify that, since it always works out in your solution that you're working with the numerator, I mention that step, but I really don't illustrate it in my written solution. But that's acceptable because we're not making any mistakes. Alright. Now here's a point of discussion. We have this equation now that does not have any fractions. Okay? I want to solve this equation. The equation that they want me to provide a solution set for has these fractions in it. Now, it so happens that most of the time you can think of these having the same solution set. But when they are different, this one that I've highlighted in gray might have some solutions to it that are not solutions to the original equation. As far as that original equation is concerned, we refer to these other solutions as extra solutions or extraneous solutions. Solutions that satisfy this equation in gray, but really don't satisfy the equation of interest, the original one they gave me. But there's an advantage to solve. It's so easy to solve that equation in gray. That's how you kind of argue that yes, it may not provide the solutions, but I can use it to determine the solutions by just checking my answers. So the checking for extraneous solutions is the technique that we use to solve it. You're not just checking your work, which is always a good idea, but the technique requires that we check our solutions. So we have one equation and one unknown. So we combine like terms. We want to collect the x's on one side of the equation, the constant terms on the other. On the left hand side, let's just leave this alone for a second. And on the right hand side, we've got these two x terms that are like terms, and 12 x's take away 5 x's, leave me with 7 x's. And we've got these constant terms. 19 minus 15 is 4. So to avoid a negative sign, I'll subtract 3x from each side of the equation, and I'll also subtract 4. When I subtract 3x from the left-hand side, that term goes away, and 7 minus 3x is 4x. When I subtract the 4 from each side of the equation, that 4 goes away, and 12 minus 4 is 8. And it's obvious that 4 times 2 is 8, or in other words, the inverse operation of multiplying by 4 is to divide by 4, and 8 divided by 4 is 2. But I think by inspection you can just look at it and see 4 times 2 is 8. Now, that's not necessarily my final answer. That's just at this point in the game, it's just a possible answer. I need to plug that in to the original solution to make sure that it checks. So let's do it over here because we have so much room over here. If we plug in this 2 on the left-hand side, we'll have the 3 in the numerator, and 2 plus 3, 5 will be in the denominator. And the question is if we do that on the right-hand side, will this arithmetic result in 3/5? So let's plug it in and see. We've got, hey, let's use the calculator. Alright, so here's my calculator. My first numerator here, I'm going to put it in parentheses. I've got 12 times 2, which I know is 24, plus 19. That's my numerator. I'm going to divide that by my denominator, and I'm going to put that denominator in parentheses as well. I've got 2 squared. Well, it's just easier for me to type in 4, plus 7 times 2 is 14, plus the 12. Close that parenthesis. That is my first fraction, my first term there. Now, I'm going to subtract from that 5, and I don't have to put the 5 in parentheses, it's just a single term, but in this denominator I need, well, 2 plus 4, I can do that in my head. 2 plus 4 is 6. Alright, so hey, whoa, did I make a mistake? Let me check real quick. And talking, I'm going to pause it and check, and I'll be right back. Oh, I am sure people are laughing at me. Of course, 3/5 is 0.6. 0.6 written, this is embarrassing. 0.6 written as a fraction is 6 over 10 because it's 6/10, and 6 over 10 is equivalent to 3/5. So yes, this checks. So although I hope that you are using the videos and enjoying the videos, I hope very few of you see these problems when I make a fool of myself on tape. Alright, let's take a look then and see if I can mess up problem number 8. Alright, I need to factor my denominators here. So in the first one here, I see a 2 appearing in both of those places. So I'm going to factor out the number 2. In the next one, I see a 4, in both of those places. And over here, I can't factor that denominator. So that middle term right there, 4 times a plus 1, that's the denominator I would like to see everywhere. On the first term, it's missing a factor of 2. 2 times 2 is 4. So we multiply this first term by the number 1. But we write 1 in such a way that we get a 4 in the denominator. This 2 times 2 will get me the 4. This denominator I leave alone. It's the denominator that I'm looking for, that I want. It's my common denominator, or will be my common denominator once I multiply it by these other terms by the number 1, but I'm going to write 1 in such a way over here that I get that missing factor of 4. So, like I say, the 2 times 2 gave me 4 times quantity a plus 1. So I have a times 2. Then we typically write it as 2 times a. I have my 2a minus 16. That was the numerator. I didn't do anything to that term because it had the denominator we wanted. And I have 4, and I need to distribute it to this binomial, 2a minus 3. So here is my resulting equation once I have cleared the denominator. And we know that the solution set to this equation may not be the solution set to my original. It may have extra solutions or extraneous solutions in reference to the original problem. 2a plus 2a is 4a. Let's distribute the 4. Let's collect the a's on the left hand side. Let's add 12. And a solution to this equation is a equals negative 1. Now, when we go to plug that into the original equation, you can see when you plug it in that 2 times a negative 1 is negative 2, and negative 2 plus 2 gives us a 0 in the denominator. So we know that this is an extraneous solution. Although it satisfies this equation, it does not satisfy our original. It was the only possibility we had for a solution set of the original. Eliminating that means that we have our original equation has no solution. Alright, let's move on to the next problem. Again, we focus on the denominator. We try to determine what common denominator we need, but we need all of the denominators to be in factored form to make that recognition, to make it easier. Otherwise, I can't look at it and just see what factors I need in every denominator. Now, hopefully, this guy factors to where t plus 7 is a factor, or t minus 2, or both. Well, it turns out both. If I have t plus 7 times t minus 2, the 7 times the negative 2 gets me the negative 14. I add the 7 and negative 2 and get a positive 5. That's the denominator that we want to see everywhere. Now over here, this guy is missing a factor of t minus 2. So again, we can't just come in and put the t minus 2 there unless we put it in the numerator, because this fraction simplifies to 1. And 1 is the multiplicative identity. Whenever you multiply by 1, you get the identical thing back. We have 1 over t minus 2. We have t plus 7. Alright, so let's take a look here. Do we have a common denominator? Yeah, because all these guys, see, the order of multiplication is not important. We have plus 7 first over here and then second factor there. 2 times 3 is the same thing as 3 times 2. Multiplication and addition have that property that's known as the commutative property. Now subtraction is not commutative. If you have 2 minus 3, that's not the same thing as 3 minus 2, but multiplication and addition, the order doesn't matter. Division, it matters. Subtraction and division are not commutative. Okay, so let's clear this denominator. Every term gets multiplied by that common denominator, and what we have left is the numerator. So this resulting equation may provide us the solutions to the original. It could provide us ones that are extra though, and that's why we have to check for. Alright, let's distribute the 2 through there. Let's combine like terms. Let's collect the variables on the left-hand side by subtracting 1t from each side. And let's the constants on the right-hand side by adding 8 to both sides. And then it should be obvious that 5 times 3 is 15. But like I say, we need to check and see if that satisfies the original equation. Now, let's go ahead and use our calculator. On the left-hand side, we have 2 fractions. On that first fraction, I have multiple terms in the numerator, so I'm going to put parentheses around my numerator. I've got 4 times 3 minus 4. Now, that's going to be divided by, and again, in parentheses, I put it in parentheses, 3 squared plus 5 times 3. Most of this arithmetic we could have done, but just when I saw the fraction, and plus it gets people a chance to see how to plug it in their calculator and how you're supposed to use parentheses in your numerators, denominators, and when to. With a single term, I didn't need parentheses. With multiple terms, I need to tell them do everything in that parenthesis first and put that number in the denominator. So I've got 3 plus 7, which we know is 10. Now, that's the left-hand side. We don't yet know if this is an equal sign. So when you do that arithmetic on the left-hand side, you get the number 1. Well, I don't have to use the calculator for the right-hand side. 3 minus 2 is 1, and 1 divided by 1 is 1. So the left-hand side evaluated to 1 when we substituted in 3 for t. And on the right-hand side, we also got 1. So we say that this checks, and that is in my solution set. It's the only thing in my solution set for this original equation. Number 10. Now, every once in a while they throw one like this at you that can confuse students because that 2 isn't written as a fraction. You know, how can you identify the denominator? Well, we can take anything and divide it by 1 just like we multiply it by 1. We're not changing that value of 2 if we write it as 2 divided by 1. Now I can look at the denominators and say, well, these other denominators, well, actually, these are different. I want to multiply all of these denominators together to have a common denominator. So this 2x over x plus 2, it's missing a factor of x minus 2. So we have to write that so that we're not changing the problem, multiplied by the number 1. This factor of 1 is missing both of those factors. So I'll write this value as the number 1 and times another 1. So now with this fraction, when we multiply all those together, its denominator will be x plus 2 times the quantity x minus 2. And on the right hand side, try that again, we have x minus 8 over x minus 2. that is missing a factor of x plus 2. We have a common denominator for every fraction. Those denominators clear. If we were to multiply every term by that least common denominator, those denominators would cancel. So I just simply say, hey, that they'll clear, indicating if you did that multiplication, this is the result that you would get. This equation doesn't have any variables in a denominator because we've cleared them, and we're hoping that it will have the same solution set as the original, but it may have extra solutions the original doesn't. So let's find the solution set to this equation. Let's distribute the 2x through. 2x squared minus 4x. Let's distribute the, oh well, I'm going to first multiply those together before I distribute. That's a special product, and that's x squared minus 4. Now over here I have x squared minus 6x minus 16. Alright, now 2x squared minus 4x minus 2x squared plus 8. Quadratic equation, I'm trying to now get 0 on one of these sides. So I'm going to get 0 on the right hand side. Let's put a 1 in front of there. By taking 1x squared away from each side, I'll have just a 1x squared there. Oh, you know what? Hey, I didn't pay attention very well. This 2x squared and that 2x squared cancel each other out. So actually, I'm going to get 0 on the left-hand side. I'm going to leave that 1x squared right where it's at. I'm going to add 4x to both sides to get minus 2x. And I'm going to subtract 8 to get a minus 24. Alright. If I can't factor that, the quadratic formula will always work. However, we can factor this to x minus 6 times x plus 4. And that gives me possible solutions of 6 and negative 4. Now, will they check? Got to have this a little bit bigger so I can see it. If we plug in 6 into the left-hand side, we get 12, and 6 plus 2 is 8, minus 2. And the question is that going to equal if we have 6 minus 8 over 6 minus 2? So if I get a common denominator with these guys, well, what if I reduce that? 4 divides each of those. And now, if I write that 2, 4 over 2, and this guy reduces to negative 1/2. Well, the question is, what is this right-hand side also going to reduce to negative 1/2? 6 minus an 8, hey, that's a negative 2. 6 minus 2 is a positive 4, and that reduces to negative 1/2. So, hey, this guy checks, this 6. But what about the negative 4? We don't know yet. We've got to check it. On the left-hand side, on the right-hand, oh, excuse me, I'm still on the left-hand side. Question is, will that equal on the right-hand side negative 4 minus 8, negative 4 minus 2? Oh, so what do I have? I've got a negative 8 divided by a negative 2 minus 2. That guy is a 4, and 4 minus 2 is 2. Now the question is, what do we have over here? A negative 12 divided by a negative 6, and hey, that's 2. So this guy, so they both check. The solutions to this equation without the fractions is the same as the solution set that we were given. Alright, now again, it's very similar to the last problem. Or, yeah, because we had that 2, well now we've got a 3 and we've got to look at it as 3 over 1. So this 4a over a minus 3 is missing a factor of a plus 3. And this 1 is missing both of those factors. Now, let's shrink this up just a little bit. On the right-hand side, a minus 3. So, what do we have? All of these are common denominators. If I were to multiply every term by that common denominator, they would all cancel. So I just, in general, refer to that as clearing the denominators. And I have 4a times a plus 3 minus 3 times a minus 3 times a plus 3 and 3a minus 1, a minus 3. So let's use the distributive property and see if we can simplify this. 4a squared plus 12a. I'm going to do this product first, and then over here alright, let's distribute that. We have a quadratic equation. We want to get 0 on one side, and 0 on one side and everything else on the other. So let's collect the a squareds over here. So here, let's 4a squared take away 3a squared just gives me an a squared plus 12a plus 27. Over here, 3a squared minus 10a plus 3. To get a positive leading coefficient, I'm going to take 1 away. I'm going to move everything to the right hand side. Subtracting 12, subtracting 27. Now all of those numbers are divisible by 2, so to make the arithmetic easier on me when I go to try to factor it, really in factoring, that is our typically we just don't factor, we say divide by 2. Alright, this factors a minus 4, a plus 3, or when negative 4 times a positive 3 is negative 12, and when you add them together, the negative, oh, that's negative 1. What did I, oh, hey, 1 and 11 are not the same. Boy, that wasn't very smart, was it? Let's try a minus 12 and a plus 1. Negative 12 times a positive 1 gets me negative 12, and when I add those together, I get negative 11. Sorry about that. Alright. You know, we've got so much clutter here. Let's go to another page to where we can just work a little bit better. Let's take our original problem with us as well. Alright, so by the zero product theorem, we've got that this guy's either equal to 0, which means a equals 12, or that equals 0, and we've got negative 1. So we need to check those. So on the left hand side, 4 times 12 is 48. 12 minus 3 is 9. minus 3. And the question is, will that equal, if we plug in 12 over here, 36 minus 1 is 35, and that's 15. So let's plug that in the calculator. If I have 48 divided by 9 minus 3, question is that 2 1/3 will that be the same? I have 35 divided by 15, and I believe it will. Yes, so the 12 checks. So hopefully the arithmetic with the -1 will be a little bit easier. We've got -4, and here -1 minus another -4. And the question is, on the right hand side, well, we'll have -3 minus 1, that's a -4. We'll have -1 plus 3, hey, that's a 2. So over here, I have 1 minus 3, which is -2. And over here, -4 divided by +2 is -2. So it checks. So we're good. Both of those satisfy the original equation. These are both in the solution set. Alright, our last problem for part 2. Factor the denominator. Factor each denominator. Alright, I look at the denominators and I have to determine what do I want as a common denominator to appear everywhere, and there it is. I want x plus 2 times the quantity x minus 2. So, in this first term, I don't have that. But I can easily get an x minus 2 if we multiply by the number 1. Since this has the denominator I want, I don't have to do anything to this term. And over here, that's just 1, so really what we want to do is to rewrite the number 1 as x plus 2, x minus 2, over x plus 2, x minus 2. Now, every denominator is the same. They are common. And by multiplying every term by that least common, or that common denominator, I guess we don't know if it's the least, yeah, it is least in terms of exponents, I get x minus 2 in the numerator, 4 in the numerator, and over here I find it pretty easy to multiply x plus 2 times x minus 2. So I have x plus 2, x squared minus 4, a quadratic equation. Let's get it in standard form. Let's get it equal to 0. We'll have the 0 on the left-hand side. We'll move the term over here by subtracting x from both sides. If we subtract 2, can we factor that? Well, I believe that we can. X minus 3, x plus 2. These yield two possible solutions. 3 or -2. But -2 I can immediately cross out. Look right here. -2 and +2 give me a 0 in the denominator. That means that this -2 is extraneous. It satisfied this equation, but not our original. So let's check the x equals 3. 3 plus 2 is 5. 3 squared is 9, and 9 minus 4 is 5. Together, that's the number 1. Hey, on the right-hand side, it says that it equals 1. So the other number, x equals 3, checked. Both of those were solutions to this equation, but not both of those were solutions to our original, only the x equals 3. These guys will always have the same, with that, like in this example, that this one highlighted in yellow might have extra. So in reference to the original equation, we say this is extraneous. So I hope that helped with part 2. Let me know how things are going. You can request that I make more videos, or I don't know, make requests and we'll talk about it. I can't always predict the way you're thinking. So just continue to study a little bit every day. Don't get behind. Attendance, and by attendance, when you're here, you got to pay attention. Not paying attention or having a rough day and falling asleep is just like missing it, in this math class. And then it can become a psychological battle. It becomes just mentally tough to have that feeling of being behind. And so to catch up, you got to work harder and power through it. So I hope this helps, and I'll talk to you later.